Welcome to lesson 4.5. In this lesson, we're basically going to do a lot of different story problems using exponentials and all the logarithms and all the things we've learned so far in chapter 4. Now, to start off, we're going to have a bunch of equations in this chapter. But the good news is you do not need to memorize the equations for this lesson. Let me give you an example. Here is our first equation, right here. And you will note it has this right here. This is on your reference sheet. You may have noticed that on the back of the front cover of your textbook, we have this paper. This reference sheet is the exact piece of paper that will be given to you during your 1050 final. So all the equations on this paper you don't need to memorize. There are a lot of things in 1050 you do, but these equations you do not. They will be given to you. However, the tricky part that will be up to you is being able to look at these equations and know what they mean, because you'll notice that none of these equations are labeled. It doesn't have any labels as to what the equation is for or what the letters in the equation mean. That's up to you. So you don't have to memorize the equation itself. You do need to memorize what the pieces of the equation mean. So that's something I want to focus on today. As we get to each equation, we're going to label each letter and what that letter means. So let's start with this equation. This first letter we have right here is A. A stands for the final amount of whatever you have. Meanwhile, P stands for the starting amount of whatever you had. So whatever you start with, we put in for P. That's basically the principal. Whatever you end with, the final amount, that's what we put in for A. Now, next we also have R. R is your interest rate, or basically your rate of growth. How fast is whatever you started with growing? And then we have N. N is an interesting one. N is the number of times per year that something is happening. So usually we call this as compounded. So if you're compounded monthly, then N is 12 because it's compounded 12 times a year. If you're compounded weekly, then it's 52 because there's 52 weeks in a year. If it's compounded daily, then N is 365 because there's 365 days in a year. And then the last variable we have in here is T, which of course, as always, stands for the time that has passed. So that is the part that's up to you, is knowing what each of these letters mean so you know where to plug things in. So let's try our first example with this. Example 1. Now, as I read through these problems, I like to have my highlighters handy, and I like to highlight the numbers and label what they are. So is it an A, a P, an R, an N, or a T? So let's start with example 1. Suppose $2,000 is invested in an account. So that means that $2,000 is going to be a P. That is your starting amount. That's how much is originally being put into the account. Then it says earning 3% annual interest compounded monthly. So that 3% is my R. That's my rate of growth. And I also have over here it says compounded monthly. So that tells me that my N is going to be 12. So hopefully that makes sense, reading through the problem and highlighting what each number means. So then it's pretty quick and easy to just plug them into the equation. So if we look at A, it says how much will be in the account after 6 years. Well, that's definitely a time because it's years. So let's plug all of these into our equation, where they're supposed to go, and see what we get. So we have 2,000 is our P. Parentheses, 1 plus R. This is given to us as a percentage, but we always want to write R as a decimal. So move the decimal place 2 places to the left, and that will give you your decimal. So here's my decimal, move it 2 to the left, and I get 0.03 divided by my n, which is 12, to the 12, because that's my n, times my t, which is 6. So once again, this equation you don't have to memorize. That will be given to you on a sheet. You just need to remember what each of these numbers means so you know where to plug them in to the equation. Now, the nice thing about all of this is we can just type all of that into our calculator, just like that, and you're going to get $2,393.90. So after my $2,000 has been sitting in this account for 6 years, I now have almost $2,400. So that's how much I've earned in interest as I've trusted the bank with my $2,000 of money. Let's try another one. We don't have the 6 years anymore. This is a new problem, so I don't know what T is. However, I'm still using the same P, R, and N. So this one says, how long will it take for the value of this account to reach $3,500? Well, that $3,500 is a final amount, so that is A. So if I write in what I know, I have A, my P, R, and N are still the same. However, this time, I do not know what T is. I'm solving for how long will it take. So I have this. Let's simplify as much as we can down, because I can simplify that to, if I just put this middle part into my calculator and change it into a fraction, it gives me that. Remember, we don't want to cut off any decimals until the very end of the problem. And now this looks an awful lot like the equations I've been solving the last 2 lessons. I need to solve for t. So let's start by getting the exponential by itself. So 3,500 over 2,000 is 7/4 equals this exponential. Now that I have the exponential alone, I know that I can change the form. So log base stays the same, and then input and output flip places. And now I only have one step left to solve for t. Divide that whole thing by 12, and I know it looks kind of ugly, but you can still type it into your calculator. So if we type all that into our calculator, we're going to end up with 18.67, and I know that this is going to be a years. So that's a couple examples. Let's now look at C. So in C, I have the same P, R, and N. However, I don't have the same T or A that A and B have. So let's read through C and see what we've got. How long will it take for the principal of 2,000 to double in value? So that double in value, that's a final amount. That's our A. So it's basically saying that A needs to be 4,000 because I want it to double in value. So we're going to set this up, 4,000. I have the same P, I have the same R, I have the same N. So it looks like, once again, I am solving for T. So we have all that. Now, because this is extremely similar to the last problem, I would like you to pause the video, try to solve this on your own, and then come back to check your answer and see how you did. Check your answer with my answer. So I solved all this out very similar to the last one, and I got about a little more than 23 years. So it'll take 23 years for my $2,000 to just sit in this account and double to $4,000. Let's try one last example for this video. We do not have the same P, R, and N. We're starting totally new. So as we read through this, let's label what we've got. Suppose we want to invest $10,000. So that means that $10,000 is going to be our P. That's our initial amount, our starting amount. And hope to have $15,000. So that's our final amount. That's A. In 8 years. So that 8 years is our T. That's our time. And it says, what interest rate compounded annually, so that's my N equals 1 time per year annually, must we seek to achieve this desired result? So let's plug in what we've got. I have my A. I have my P. I do not know what my R is. I know my N is 1. And my T is 8. So here's this equation. I can simplify this down a little bit real quick, because I know R divided by 1 is just R, and 1 times 8 is just 8. So once again, I would like you to pause the video, try to solve this out on your own, and then come back to check your answer and see how you did. Check your answer with mine. So I divided by 10,000 first, and then I had to the 8th power, so I took the 8th root to get rid of that. And then I just minused 1, so I had the 8th root of 3/2 minus 1. Type that in my calculator, I get this. Or I can move the decimal over to the right twice to change it to a percent. So that is the interest rate I need in order for my 10,000 to change to 15,000 in 8 years. So that is all we're going to do concerning this formula. This is our compound interest formula. In the next video, we're going to get a new formula and try some new examples using that formula.